Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Dini Ashraf Pirosli and my matrix number is B0222100098. So today I will be present about my final year project, IoT Integrated Smart System with Predictive Analysis for Personalized Tracking of Carbon Footprints. And my supervisor name is TS Siti Rosmaniza binti Abdul Rashid. So, let's move to the introductions. What is carbon footprints? Carbon footprints is produced directly and indirectly by human daily activities. There are three types of carbon footprints: waste, energy, and petrol consumptions. By understanding the carbon footprints, it helps individuals and organizations reorganize their environmental impact and seek ways to reduce it. By reduce the carbon footprints, it helps mitigating the climate change, preserving ecosystems for sustainable future for the planet. So next, let's move to the problem statement. There are two problem statements in this project. So the first one is household emission issue. As we know, household is the major contribution of carbon footprints due to poor waste management, high energy usage, and efficient fuel consumption. By having the traditional method and lack tools to support sustainable habit, there are strong need to have a smart system that can monitor the three type of carbon footprints. Next, the second limitation of current tracking. There are existing carbon footprints method are too general, and without AI driven, the user cannot measure the three type parameter accurately and to improve their environmental impact. So, by integrating AI and machine learning, a smart system can provide a real monitoring data, make accurate predictions, and give personalized recommendations to help households make better environmental choice. We move to the objective. There are three objectives in this project. So the first one is to develop a system that automatically detect waste volume, energy usage, and petrol usage to analyze carbon footprints. The second one is to create a mobile apps that allow user to view carbon footprints data based on log of fuel, energy, and waste usage. And the third one is to analyze carbon footprints data and future forecast emissions by identifying user behavior trends based on carbon footprint factors. This is the carbon footprints calculation. There are three parameters of carbon footprint here. The first one is waste in kg, energy in kilowatt hour, and petrol in liter. So we need to calculate by the raw data of waste in kg will be timed to with 0.497 carbon emissions, and then the energy we will calculate in kilowatt hour times with 0.758 carbon emissions, and petrol in liter times with 2.345. This is the universal carbon footprints calculations, and to calculate the total carbon emission, waste, energy, and petrol in carbon footprints will be sum, and that is the total of carbon emissions. Next, let's move to the hardware. This is all the component and the sensor that are being used in this project. On the right side is the model. As we can see in the front view, there are two dustbin there for recycle and non-recycle waste. And the close view, we can see that the camera will be integrated for classification of waste, and the motor will do the segregations. And the top view here, we can see that the current sensor is connected to the extensions where it will calculate the kilowatt hour measurement and send it to the Raspberry Pi to do the calculation of the carbon footprints. So this is the modern tools that are being used in this project to create the application and the software. Next, this is the application's user interface where we can see the petrol manual key in, live monitoring UI, waste level alert notifications, and also the AI recommendations in the applications. So this is the data collected based on the application. As we can see on the first graph, there are for energy in kilowatt hour. The second one is waste in recycle and non-recycle in kilograms, and the third one is the graph for petrol in liter average consumption, and the last one is the carbon footprints producer data. This is the result from the applications. The first one is the total of carbon footprints produced in 30 days. The total is 392.25 kg carbon emission. The AI insight will tell the biggest contribution of carbon footprints parameter, which is fuel, for 75.6%. Then the AI recommendation will show the level of each parameter and the carbon footprints. It have three levels, which is efficient, moderate and critical. It's also have universal action step for reducing the carbon emissions. And lastly, the AI summary will do the summarize based on the data collected and show the improvement that could reduce the carbon emission by approximately. So let's move to the video demonstration. This is the non-recycle waste segregations, and then for the second one is the recycle waste segregations in the hardware or the model that are being used to the project. This is the application of monitoring the carbon footprints. So in this application, the first user interface will see the petrol manual key in for the user to manually key in the data of petrol, and then this is the live monitoring where the user can see the total of carbon footprints productions data. This is the kilowatt hour energy data, and then this is the waste data in kilogram for the recycle and non-recycle graph. And then we move to the petrol consumption data for the average consumption data, and this is the carbon footprints data. Also, we can move to the AI analyze where the user can see the AI recommendations. This is the AI insight, and this is the AI recommendations based on the data collected. And also the last one is for the AI summary. For the first graph, it's present the predicted carbon emission generated using a linear regression machine learning model trained on historical data. Include the parameter of the carbon footprints. The dashed line represent the predicted carbon emission trend, showing natural fluctuation that reflect variations in user behavior and system usage. A noticeable peak indicates a period of higher estimated emissions. These predictions help visualize future emission trend and support planning, monitoring, and carbon reduction strategies. So for the second graph, it's compare actual carbon emission with a simulated optimization scenario generated from AI-based recommendation within the applications. The optimized curve does not represent measured data but demonstrate the potential reduction achievable through improved the parameter of carbon footprints, and then complete reductions is not achievable due to the real world constraints, user behavior, unavoided activities, and baseline energy requirements. This slide explains the sustainable design and commercialization potential of my project. First, the system supports several sustainable development goals. For SDG 7, energy consumptions is monitored in real time and convert into carbon emissions to promote efficiency electricity usage. For SDG 11 and SDG 12, the system use smart waste classification to automatically separate recycled and non-recycled waste, supporting better waste management and responsible consumptions. For SDG 13, the total carbon footprint of waste, energy and petrol usage is calculated and visualized to support climate actions. In terms of commercializations, this system is suitable for organizations such as TMB and Malakoff to identify energy efficiency, Petronas for carbon reductions and decision support, and MGTC is supporting Malaysia low carbon nations and energy technology innovative. In conclusion, in this project, I successfully combine IoT machine learning and predictive analysis to provide real-time monitoring and automated calculation of carbon footprint for waste, energy and petrol usage by giving user personalized insight and live visualizations. The system enables informed decisions that can reduce carbon emissions, promote sustainable behavior, and support global effort toward climate actions and SDG 7, 11, 12, and 13.